In this video, I'm going to be going through the major types of 3D data you would expect to encounter when working with scanned specimens. The first data type I'd like to touch on is called a mesh. You are already familiar with meshes, even if you don't know it, because they are the data type that are used to create CGI animation in movies and video games. They are essentially 3D surfaces composed of many small flat planes called polygons. If I zoom into this mesh of a fossil beaver skull here, you can start to see the polygons on the surface. If I click on this edge highlighter, you can see them even more clearly. Typically, the polygons are triangles in a nice clean mesh, but sometimes you can get polygons with more sides. One distinctive feature of meshes is that there's nothing inside of the mesh. So if I scroll in here, you can see that it's essentially an empty shell. This is an important distinction from the second data type I want to show you today, called volumes. Here in Slicer, you can see the volume I have pulled up right now. It may just look like an image, but that's because volumes are a stack of images that stack together to form one coherent 3D object. So I can scroll through my stack and you can start to see the different slices through this rodent jaw. In each image, the pixels define how dense each part of the image is. So this outside black part here is the least dense part of the image, or just the air that was surrounding the fossil when we scanned it. And the whitest stuff is the densest part, or the fossil itself. See here you can see things like the teeth and the outer jaw. The gray is an in-between density, which in this case is the rock matrix. Programs like Slicer can render these image stacks as one complete volume. So here you can see the volume rendered in 3D. This is rendered differently from how the mesh rendered a 3D object, because instead of having just the surface composed of polygons, now Slicer is rendering inside and outside of the object using little cubes called voxels. And in fact, I can actually slice into this volume and look at what the inside looks like. So you can see here, unlike the mesh, you can see all of the structures inside the volumes. We can also see this by using the shift toggle, which basically clips out the lower density voxels. So here I'm showing all of the voxels. Obviously that's just a cube because it's the entire image stack. But then once I shift it down, the air starts to disappear. In fact, here you can even see the foam this was resting on. And then we start to make the inner matrix disappear. And finally, all but the most dense parts of the fossils. Only CT data is going to generate a volume that has the internal and external structure. Surface scanning directly generates a mesh. However, meshes are required for almost all kinds of analysis, so inevitably you will end up having to generate a mesh from the volume for a CT scan. Volumes and meshes are both broad categories of data formats, similar to how an image could be either a JPEG or a PNG format. For volumes, you may find volumes that are just folders of images, numbered sequentially. These require you to have external information about metadata like the scale of the pixels so that you are getting correct scale information. My personal favorite format to use is the NRRD, or Near Raw Raster Dataset. This is all packaged as one file as opposed to a folder of many images, and it contains metadata like the scale of the pixels. Finally, you might encounter DICOM data, which is specific to medical CT scanners and does come as a folder of images, but it also contains a lot of metadata as well. Meshes come in a variety of formats. I've just listed a couple here. STL, OBJ, and PLY. STL and OBJ are the two you're most likely to encounter. I know many open source programs tend to prefer OBJ. I lean towards STL because it's always a single file, whereas OBJ can contain multiple files, such as a texture file to define the colors of this on the surface of the mesh or things like that. And then PLY is useful for as a simpler data format for things like R. So, as you might guess, these two data types have very different uses. Volumes are great for being able to view internal anatomy, as well as take basic measurements. However, they are very limited beyond these two tasks, and typically, again, you'll have to generate a mesh from the volume, which we'll go over further on. Meshes, on the other hand, are very versatile. They can be used in things like computer modeling, 3D printing, and they are generally the better way to share data because they are much smaller files. Two other 3D data types you may encounter are 3D PDFs and CAD models. 3D PDFs are only good for sharing visualizations of 3D data. It's very difficult to export meshes from these, so for instance, if you wanted to include a 3D model in a paper, but you didn't want people to be able to work on that specific model, a 3D PDF might be the way to go. Otherwise, I suggest avoiding them just because they can be difficult to do anything with. CAD models or solid meshes are specific to computer-aided design programs, which are much more engineering focused. I am not entirely familiar with them, but I do know that they are required if you're going to do things like finite element analysis. Bottom line is that usually you will want a mesh for further analysis. Of course, this does depend on your project, but more often than not, that will be the data type you are aiming for. Fortunately, you can generate meshes from volumes through a process called segmenting, and this is essentially where you select the structure on the volume that you want to create a mesh from, as you can see in the skull below. I've selected the skull, not the air, and not the matrix inside the skull. And just as an aside, why CT scan if you're going to need a mesh anyway? It's because often, especially with fossils, you'll want a mesh of the internal structure of the object. So on the left here, you can see what would have been an external mesh of two vertebrae that are stuck together. And on the right, I have this mesh that was generated from the CT scan that allowed me to see the internal structure, like the two articulations right here that were otherwise covered in the fossil itself. So CT scanning is still a great tool when you need to get to internal anatomy, even if you're ultimately going to be using meshes.